Hi everyone. Welcome here, to this quiet place, this gentle, unhurried space. We're going to share together. For a little while, we're going to spend some time together, exploring the quiet mysteries of space, not in a rushed or exciting way, but very slowly, very gently, as if we are simply wandering through the universe. On a calm, dark evening, with no particular place to be, and no particular time to arrive, space is a vast and peaceful thing, mostly empty, mostly still, mostly silent, and in that silence, there is something very soothing, something that has always drawn people to look upward on clear nights and simply wonder. We're going to do that tonight. Wonder, quietly, about the stars and the planets, about light and time and distance, about all the soft, slow, beautiful things that fill the universe. And if, somewhere along the way, your eyes grow heavy and your thoughts begin to drift, that is perfectly fine. That is more than fine. That is exactly what this is for. So take a slow breath in and let it out gently, and let us begin. Fact 1. Let us start with something very simple and very calming. Space is almost entirely empty. If you were to take all the matter in the observable universe, every star, every planet, every moon, every grain of dust, and spread it evenly throughout the entire volume of space, the average density would be roughly equivalent to just a few hydrogen atoms per cubic meter. A single cubic meter of air here on Earth contains around 25 billion molecules. And yet, out there, in the vast reaches of space, you would find only a handful of atoms in the same amount of room. Space is, more than almost anything else we can imagine, a place of quiet emptiness. And there is something gently comforting about that. The idea that the universe, for all its vastness, is mostly made of nothing at all, just stillness and space, and a very, very soft quiet that stretches in every direction, without end. Fact 2. Now, as we continue, let us think about light. Light travels at an extraordinary speed, roughly 300,000 kilometers, every single second. That is fast enough to circle the entire Earth, about 7.5 times, in just 1 second. And yet, even at that remarkable speed, the distances in space are so enormous that light still takes a very long time to cross them. The light that is reaching your eyes right now, from the nearest star beyond our own sun, a star called Proxima Centauri, left that star approximately 4 years and 3 months ago. So when you look up at that little point of light in the sky, you are not seeing the star as it is tonight. You are seeing it as it was 4 years ago. You are, in a very gentle way, looking back through time. Every glance upward at the stars is a quiet journey into the past. And that is a rather beautiful thought to carry gently with you. Fact 3. Gently moving forward. Let us consider the sun for a moment. The sun is our nearest star, and it is a remarkably calm and steady thing. From our perspective here on Earth, it rises every morning, moves slowly across the sky, and sets every evening, in a rhythm so dependable that we have built our entire sense of time around it. The light and warmth that the sun provides travel through space for about 8 minutes and 20 seconds before they reach us. So the sunshine on your face, on a warm afternoon, actually left the sun about 8 minutes earlier. In those 8 minutes, that tiny packet of light crossed 150 million kilometers of nearly empty space, silently, without effort, traveling in a perfectly straight line, at the speed of light, and then it simply arrived, fell on your skin, warmed you, gently. That is a quiet kind of miracle, isn't it? One that happens again and again, day after day, without fanfare. Fact 4. Let us take a quiet moment to think about the moon. Our moon is not a particularly large moon, compared to some others in the solar system, but it is wonderfully familiar to us. It has been drifting slowly, in orbit around the Earth, for about 4.5 billion years, roughly as long as the Earth itself has existed. The moon is slowly moving away from Earth, a tiny bit each year, about 3 to 4 centimeters per year. Over the entire span of human history, the moon has drifted perhaps a few hundred meters farther from us. You would never notice. The moon appears just as large, and full, and round, as it always has on clear nights, hanging there in the darkness, with a soft, borrowed light, reflecting the sun's glow, back down toward us. It will continue to drift, slowly, gently, for billions of years to come. There is something restful in that continuity, something that makes the night feel deeply, quietly safe. Fact 5. Slowly, gently, let us think now about the vastness of our galaxy. The Milky Way, the galaxy we live in, contains somewhere between 100 billion and 400 billion stars. That is a number so large, it is almost impossible to feel. If you tried to count to just 1 billion, counting one number every second, without stopping, it would take you over 31 years. And our galaxy has hundreds of billions of stars. Each of those stars is a sun, many of them, with their own planets orbiting around them, their own moons, their own asteroid belts, perhaps their own versions of Earth. When we look up at the soft, hazy band of the Milky Way, on a clear, dark night, that faint, gentle smear of light, stretching across the sky, we are looking at the combined glow of hundreds of billions of distant suns, all of them quietly burning, slowly, steadily, in the dark. Fact 6. Now, as we continue, let us think about how stars are born. Stars begin as clouds of gas and dust, mostly hydrogen, drifting slowly through space, in vast, cold, dark regions, called nebulae. Over millions of years, gravity gently pulls these clouds together. Slowly, the material begins to condense, to gather in toward the center, growing denser and warmer. As it collapses, eventually, after millions of years of this slow, patient gathering, the pressure and temperature at the center become high enough to trigger nuclear fusion, and a star ignites. It is not a sudden event. It is a process so gradual, so unhurried, that there is something deeply meditative about it. The universe, in making a new star, does not rush. It takes its time. It gathers, and waits, and slowly, over ages, something beautiful, and warm, and glowing, comes into being. There is a lesson somewhere in that. If you want to find one. Fact 7. There is no need to rush. And so let us rest for a moment with the idea of stellar nurseries. Some regions of space are particularly good at forming new stars, and these regions are called stellar nurseries. One of the most famous is the Orion Nebula, a beautiful, glowing cloud of gas and dust that you can actually see with the naked eye on a clear winter night as a soft, slightly blurry patch of light. In the constellation Orion, inside the Orion Nebula, new stars are forming right now. This very moment, as you rest here quietly, baby stars are gathering themselves out of clouds of hydrogen, slowly condensing, slowly warming, slowly beginning to glow. The nebula itself radiates a gentle, reddish-pink light caused by hydrogen gas being energized by the young, hot stars already born within it. It is one of the most actively creative places in the nearby universe, and it is there, quietly, every time you look. Fact 8. Let us take a quiet moment to think about the color of stars. Stars are not all the same color, though from Earth, they often appear as simple white or slightly yellowish points of light. In reality, the color of a star tells you about its temperature. The hottest stars burn a brilliant blue, or blue-white. Slightly cooler stars appear white, or yellow-white. Stars around the temperature of our own sun appear a warm yellow. Cooler stars glow orange, and the coolest stars of all, still burning, still fusing hydrogen, but at a much lower temperature, appear a deep, warm red. When you look at a star and notice its color, you are reading its temperature from across unimaginable distances. The night sky is full of stars, of many different colors, many different temperatures, all at different stages of their long, slow lives, quietly glowing, quietly burning, in the vast dark above you. Fact 9. Gently moving forward. Let us think about how long stars live. Stars have lifetimes that depend very much on their size. The largest, most massive stars burn so brightly and so intensely that they exhaust their fuel in just a few million years, a cosmically short lifetime. Our Sun, a medium-sized star, has been burning for about 4.5 billion years and is expected to continue for roughly another 5 billion years. The smallest stars, called red dwarfs, burn so slowly and so coolly that they're expected to live for trillions of years. Trillions. The universe itself is only about 13.8 billion years old, so no red dwarf star has yet had time to grow old and die. Every single red dwarf that has ever formed is still burning, right now, in the darkness of space. Quietly, steadily, patiently, they will outlast everything else we know. Fact 10. Now, as we continue, let us think about what happens when a star like our Sun reaches the end of its life. When a star of our Sun's size runs low on hydrogen fuel, it begins to change. It slowly expands outward, growing into what astronomers call a red giant, a vast, cool, dimly glowing sphere of gas, many times larger than the original star. Eventually, the outer layers of the red giant drift gently outward into space, forming a beautiful, glowing cloud called a planetary nebula, a soft ring or shell of gas, often glowing in gentle blues and greens and reds. At the center of the planetary nebula, the remaining core of the star slowly cools and dims, becoming a small, dense object called a white dwarf. The white dwarf no longer burns. It simply glows quietly with residual heat, like the last embers of a fire, growing slowly cooler and cooler over billions and billions of years. Fact 11. Slowly, gently, let us move now to the planets. Our solar system has 8 planets, each one traveling along its own gentle, curved path around the Sun. The planets closer to the Sun move faster in their orbits. Mercury, the closest, races around the Sun in just 88 Earth days. The planets farther out move more slowly. Neptune, the farthest of the 8, takes about 165 Earth years to complete a single orbit. Each planet moves in perfect, quiet harmony with the gravitational pull of the Sun and the other planets around it. These orbits have been stable for billions of years. The planets have been making their slow, curved journeys through space since long before there were any eyes to watch them, before there were any ears to listen, before there was any life at all, and they will continue long after. Unhurried and constant. Fact 12. Let us take a quiet moment to think about Venus. Venus is sometimes called Earth's twin because it is almost exactly the same size as our planet, but in almost every other way, it is deeply different. Venus is blanketed in a thick atmosphere of carbon dioxide, so dense that the atmospheric pressure at the surface is about 90 times that of Earth at sea level. The surface temperature on Venus hovers around 465 degrees Celsius, hot enough to melt lead. And yet, from a distance, Venus is one of the most beautiful objects in the sky. It shines more brightly than any star, appearing as a brilliant, steady white light, often visible just after sunset or just before sunrise. Ancient people called it the evening star and the morning star, not realizing it was the same object, seen at different times. There is a quiet beauty in that, something so extreme, seen from afar, as something so soft and gentle. Fact 13. There is no need to rush. So let us rest with Jupiter. For a moment, Jupiter is the largest planet in our solar system, so large that you could fit more than 1,300 Earths inside it. Despite its enormous size, Jupiter rotates very quickly, completing one full rotation in just under 10 hours. This rapid rotation causes the planet to bulge slightly at its equator and flatten at its poles, giving it a subtly round, but not quite spherical shape. Jupiter's most famous feature is the Great Red Spot, a storm that has been raging in the planet's atmosphere for at least 350 years, perhaps much longer. The storm is slowly shrinking. It has been getting smaller for decades now. Gradually, gently, no one is entirely sure what will happen when it finally disappears. Perhaps it will simply dissolve quietly into the surrounding clouds, the way all great storms eventually must. Fact 14. Gently moving forward, let us think about Saturn and its rings. Saturn's rings are perhaps the most beautiful and serene sight in the solar system. They are made of billions of pieces of ice and rock, ranging in size from tiny grains to chunks as large as a house, all orbiting Saturn in a flat, thin disk. The rings extend outward for hundreds of thousands of kilometers from Saturn's surface, and yet they are remarkably thin. In most places, only about 10 to 20 meters thick. If you scaled Saturn down to the size of a large beach ball, the rings would be thinner than a sheet of paper. They are, in a sense, an enormous and delicate thing, vast in width, impossibly thin in depth, catching the sunlight and scattering it in a soft, pale glow. Saturn's rings are slowly fading, piece by piece, drifting down into the planet over millions of years. Quietly, slowly, they're disappearing. Fact 15. Now, as we continue, let us think about the moons that orbit other planets. Jupiter alone has 95 known moons. Saturn has at least 146. These moons range from tiny, irregularly shaped chunks of rock and ice just a few kilometers across to enormous worlds larger than the planet Mercury. One of the most fascinating is Europa, a moon of Jupiter, which is covered entirely in a smooth shell of ice. Beneath that ice, scientists believe, lies a global ocean of liquid water, kept liquid by the gravitational flexing of the moon as it orbits Jupiter. That ocean has been there for billions of years, in total darkness, beneath kilometers of ice, heated gently from within. If life can exist in the dark, cold depths of Earth's own oceans, it is possible, just possible, that something might be quietly living in Europa's hidden sea, having never seen a star, having never needed to. Fact 16. Let us take a quiet moment to think about Mars. Mars is a quiet, cold, dusty world. Its surface is covered in iron oxide rust, which gives it its characteristic reddish color. The Martian sky on a clear day, is a soft pinkish tan, colored by fine dust, suspended in the thin atmosphere. Mars has enormous, ancient volcanoes. Olympus Mons, the largest volcano in the solar system, stands about 22 kilometers tall, more than 2.5 times the height of Mount Everest. But Olympus Mons has not erupted for millions of years. It stands in silence on the Martian plains, enormous and still, watched over only by the thin Martian wind, carrying its fine red dust. Across the surface, there are rover robots on Mars right now, quietly rolling across that reddish ground, taking photographs, measuring temperatures, looking for signs of ancient water, slowly, patiently, gathering knowledge from a world we have never visited in person. Fact 17. Slowly, gently, let us think about Pluto. Pluto was once considered the 9th planet of our solar system, but in 2006, it was reclassified as a dwarf planet, a change that was somewhat controversial, but which simply reflected a better understanding of the many small, distant worlds that exist in the outer solar system. Pluto is small, smaller than our moon, and very far from the sun. It orbits at an average distance of nearly 6 billion kilometers. The sunlight that reaches Pluto is so faint that noon on Pluto would look, to our eyes, like deep twilight here on Earth. And yet, when the New Horizons spacecraft flew past Pluto in 2015 and sent back photographs, what we saw was a complex, beautiful world with mountains of water ice, vast plains of nitrogen ice, a heart-shaped region that scientists named Tombaugh Regio, and a thin, hazy blue atmosphere. Pluto, so small and so far away, was quietly extraordinary. Fact 18. There is no need to rush. Let us rest now with the idea of the void between stars. When we think of space between stars, we might imagine a sort of gentle, dark emptiness, and in a sense, that is exactly right. The interstellar medium, as scientists call it, is the gas and dust that fills the space between stars. In most places, it is extraordinarily sparse, just a few atoms per cubic centimeter, mostly hydrogen. In the densest regions, there might be a few thousand atoms per cubic centimeter, which is still far emptier than the best vacuum we can create in a laboratory on Earth. And yet, this sparse material is not nothing. It is, slowly and gently, being reshaped by the energy of nearby stars, by the gravity of passing clouds, by the slow currents of the galaxy itself. Material that was once part of a long-dead star now drifts as part of this great, thin fog between the stars, waiting, perhaps, to one day be gathered into something new. Fact 19. Gently moving forward, let us think about the Oort cloud. At the very edge of our solar system, far beyond the orbits of all the planets, there is a vast, roughly spherical region called the Oort cloud. It is thought to contain trillions of icy objects, the building blocks left over from the formation of the solar system, slowly drifting in the cold and the dark. These objects are so far from the sun that the sun appears from the Oort cloud as just an unusually bright star, brighter than others, but not overwhelmingly so. Occasionally, something disturbs the orbit of one of these distant icy objects, a passing star, perhaps, or the gentle tug of a nearby gas cloud, and it begins a long, slow fall inward toward the sun. After millions of years, of traveling. It arrives in the inner solar system as a comet, glowing briefly, with a soft tail of gas and dust, before swinging around the sun and heading back out into the dark. Fact 20. Now, as we continue, let us think about cosmic silence. In space, sound cannot travel. Sound is a pressure wave, a vibration that moves through a medium, air, water, solid material. But in the near-perfect vacuum of space, there is no medium for sound to travel through. If a star exploded right now, not too far from here, the explosion would be utterly silent. To an observer floating in space nearby, they would see a flash of light. They would feel the warmth of radiation, but they would hear absolutely nothing. No sound, only silence. The cosmos is, at its deepest level, a silent place. All the explosions of supernovae, all the collisions of galaxies, all the slow grinding of worlds against each other, happening in complete and utter quiet. There is something deeply peaceful about that. The universe goes about its business in silence, and we are small, quiet witnesses to its vast, soundless work. Fact 21. Let us take a quiet moment to think about dark matter. Most of the matter in the universe is invisible to us, not just far away, not just too dim to see, but genuinely transparent to light. Scientists call this dark matter, and they believe it makes up about 27% of the total content of the universe. We cannot see dark matter, and we cannot touch it or measure it directly, but we can infer its presence from the way it bends light and affects the rotation of galaxies. Galaxies spin differently than they would if they contained only the visible matter we can see. They spin as if there is much more mass present than we can account for. That extra mass, that hidden, quiet, invisible presence, is dark matter. It is all around us. It passes through you, through the earth, through the sun, without interacting, without leaving any trace, just silently, gently present, everywhere. Fact 22. Slowly, gently, let us rest with the concept of dark energy. If dark matter is mysterious, dark energy is even more so. Dark energy is thought to make up about 68% of the total content of the universe, making it by far the largest component of everything that exists. And yet, we have almost no idea what it is. What we do know is its effect. Dark energy is causing the expansion of the universe to accelerate. The universe has been expanding since the Big Bang, and we might have expected that expansion to gradually slow over time, pulled back by the gravity of all the matter in the universe. Instead, the expansion is speeding up. Something we call dark energy is pushing the universe outward at an ever-increasing rate. What that something is, we cannot say. It is simply there, quietly, everywhere, doing its vast, unhurried work. Fact 23. There is no need to rush. And so let us gently consider the concept of a light year. A light year is the distance that light travels in one full year, about 9.5 trillion kilometers. It is a way of expressing enormous distances in space in a slightly more manageable way. The nearest galaxy to our own Milky Way is the Andromeda Galaxy, which lies about 2.5 million light-years away. That means the light reaching us from Andromeda tonight left that galaxy about 2.5 million years ago, when our early human ancestors were still learning to shape stone tools. On the plains of Africa, you can actually see the Andromeda Galaxy with your naked eye. On a clear, dark night, a faint, soft smear of light in the constellation Andromeda What you are seeing is the combined light of a trillion stars, delayed by 2.5 million years. It is, very quietly, one of the most extraordinary things you can see from Earth. Fact 24. Gently moving forward. Let us think about the most distant things we can see. The most distant objects observable from Earth are galaxies and quasars, located over 46 billion light-years away. But wait, you might think, if the universe is only 13.8 billion years old, how can we see things 46 billion light-years away? The answer is that space itself has been expanding during all the time that light has been traveling toward us. The light that is arriving now from the most distant objects set out when those objects were much closer, but as the universe expanded, those objects moved farther and farther away. So the observable universe, the sphere of everything we can in principle see, has a radius of about 46 billion light-years. Even though the universe is only 13.8 billion years old, beyond the observable universe, there may be much more, but that light has simply not had time to reach us yet. It is still traveling toward us, quietly, through the dark. Fact 25. Now, as we continue, let us think about the cosmic microwave background. After the Big Bang, the universe was extraordinarily hot and dense, too hot and dense for atoms to even form. Electrons, protons, and photons existed in a superheated soup, constantly interacting. After about 380,000 years, the universe had cooled enough for electrons and protons to combine into atoms, and suddenly, for the first time, light could travel freely. The light released at that moment is still traveling through the universe today, enormously stretched and cooled by billions of years of cosmic expansion. We detect it as a faint, uniform glow of microwave radiation coming from every direction. In the sky, the cosmic microwave background, it is the afterglow of the earliest fire, the echo of the beginning, spread evenly across all of space, reaching us from every direction at once, softly, quietly, the oldest light in the universe, still gently arriving. Fact 26. Let us take a quiet moment to think about the expansion of the universe. Edwin Hubble, in the 1920s, made one of the most profound discoveries in the history of science. He found that the light from distant galaxies was shifted toward the red end of the spectrum, a phenomenon called redshift, and that the amount of redshift increased with distance. This meant that distant galaxies were moving away from us, and the farther away they were, the faster they were receding. The universe was expanding, not expanding into empty space around it, but space itself was stretching, carrying galaxies farther and farther apart. This is still happening right now. Tonight, as you rest here, every galaxy, not gravitationally bound to our own, is slowly, gently, drifting farther away. The fabric of space itself, quietly growing between us and them, moment by moment, without end. Fact 27. Slowly, gently, let us think about black holes. A black hole forms when a very massive star collapses at the end of its life. The core collapses so completely that it forms a point of infinite density, called a singularity, surrounded by a boundary, called the event horizon. Within the event horizon, gravity is so strong that not even light can escape. Black holes are not, despite their name and reputation, cosmic vacuum cleaners. They do not pull things in any more strongly than a star of the same mass would. If our sun were replaced by a black hole of equal mass, Earth would continue to orbit in exactly the same path it always has. Black holes simply sit in space, quiet and invisible, only revealing their presence by the way they affect things around them, bending light from background stars, slowly pulling in nearby material, sometimes creating brilliant glowing disks of gas that spiral slowly inward, glowing with a soft and ancient light. Fact 28. There is no need to rush. Let us rest with neutron stars. When a massive star, larger than our sun, but not enormous, exhausts its fuel and collapses, the result is a neutron star. A neutron star is extraordinarily dense, packing a mass greater than the sun into a sphere only about 20 kilometers across, roughly the size of a city. A single teaspoon of neutron star material would weigh about 10 million tons. Here on Earth, neutron stars often spin very rapidly, some completing hundreds of rotations per second. Some neutron stars emit beams of radio waves from their magnetic poles, and if those beams sweep across Earth as the star rotates, we detect them as regular, rhythmic pulses. These are called pulsars. The regularity of their pulses is so precise that pulsars are among the most accurate natural clocks in the universe, quietly ticking away in the dark at the rate of their own spinning. Fact 29. Gently moving forward, let us think about where our solar system sits. Within the Milky Way, our sun is located in what astronomers call the Orion Arm, a relatively minor spiral arm of the Milky Way galaxy, about 26,000 light-years from the galactic center. The galactic center is a busy, dense region of stars, and at its heart sits a supermassive black hole called Sagittarius A*, with a mass about 4 million times that of our Sun. From our position in the Orion Arm, the galactic center is far enough away that it has relatively little direct effect on our solar system. We sit in a quiet, suburban region of the galaxy, not at the crowded center, not at the sparse outer edges, but somewhere comfortable in between, in a region stable enough that our sun has been able to maintain steady conditions for billions of years, long enough for life to develop and evolve, and eventually gaze back at the stars. Fact 30. Now, as we continue, let us think about the rotation of the Milky Way, our entire solar system. The sun, all the planets, all the moons, and asteroids, and comets, is orbiting the center of the Milky Way galaxy. This orbit is called the galactic year, and it takes about 225 to 250 million Earth years to complete one full circuit in the 4.5 billion years since the solar system formed. We have completed this orbit only about 20 times. The last time our solar system was in roughly the same position relative to the galaxy. The most complex life on Earth was single-celled organisms drifting in shallow seas. We are on our own slow, vast journey through the galaxy, carried along by the gentle pull of gravity, never still, always moving, though you would never feel it from where you are resting right now. Fact 31. Let us take a quiet moment to think about the size of the observable universe. If you were to draw a circle with the Earth at the center and make the radius of that circle equal to the farthest distance from which light has had time to reach us, you would have the observable universe. Its diameter is about 93 billion light-years. Within that sphere, scientists estimate there are roughly 2 trillion galaxies. 2 trillion galaxies, each containing hundreds of billions of stars. Each star, potentially, with its own planets and moons. The sheer scale of it is beyond any ordinary kind of comprehension. And yet, here we are, on one small, warm, blue planet, orbiting one ordinary star, in one medium-sized galaxy, somewhere in the quiet middle of all that vastness. Small, yes, but here, alive, awake, and gently, quietly, wondering at it all. Fact 32. Slowly, gently, let us think about the idea that we are made of stardust. This is not simply a poetic notion. It is literally true. Every atom in your body, heavier than hydrogen and helium, was forged inside the nuclear furnace of a star. The carbon in your cells, the oxygen in your lungs, the calcium in your bones, the iron in your blood, all of it was synthesized in the cores of stars that lived and died before our solar system even formed. When those stars ended their lives in supernova explosions, they scattered their material outward into space. That material drifted in great clouds, slowly, for millions of years, until gravity gathered it together into new stars, new planets, eventually into Earth, and eventually into you. The iron in your blood was, billions of years ago, glowing inside a dying star. You carry the universe in you, quietly, everywhere you go. Fact 33. There is no need to rush. And so let us rest with the Voyager spacecraft. In 1977, NASA launched two spacecraft, Voyager 1 and Voyager 2, on a mission to explore the outer solar system. They flew past Jupiter, Saturn, Uranus, and Neptune, sending back the first close-up photographs of these worlds. And then, they kept going. Both spacecraft are still traveling outward, beyond the solar system, into the vast space between the stars. Voyager 1 is now more than 23 billion kilometers from the Sun, the farthest any human-made object has ever traveled. It carries a golden record containing sounds and images of Earth, greetings in many languages, music, photographs, a quiet message from humanity to whoever or whatever might one day find it drifting through the dark. It moves at about 17 kilometers per second and will not reach even the nearest star system for over 70,000 years. Fact 34. Gently moving forward, let us think about the concept of cosmic time. The universe is about 13.8 billion years old. Our Earth formed about 4.5 billion years ago. If we compress the entire history of the universe into a single calendar year, the Big Bang happening on January 1st, and tonight being midnight on December 31st, then the Milky Way galaxy formed in late January. Our Sun and Earth didn't form until early September. The first simple life on Earth appeared in mid-September. Dinosaurs appeared on December 25th. Modern humans appeared less than 2 minutes before midnight. All of recorded human history fits into the last 14 seconds of the year. Everything you know, every civilization, every discovery, every night sky ever looked at by human eyes happened in those last 14 quiet seconds of a very long year. Fact 35. Now, as we continue, let us think about the Hubble Space Telescope. The Hubble Space Telescope has been orbiting Earth since 1990, observing the universe from above our atmosphere, which distorts and blurs the light of stars and galaxies. From its orbit, about 540 kilometers above the surface, Hubble has photographed some of the most beautiful things ever seen. by human eyes. One of its most famous images, the Hubble Deep Field, was created by pointing the telescope at a tiny, apparently empty, patch of sky for 10 consecutive days, and collecting every photon of light that arrived. What emerged was a photograph showing nearly 3,000 galaxies, each one a complete island universe containing billions of stars, packed into a region of sky so small it would be covered by a grain of sand held at arm's length. The universe is not empty, it is full, quietly and completely, with worlds. Fact 36. Let us take a quiet moment to think about how thin the atmosphere of Earth really is. Seen from space, the atmosphere of Earth, the layer of air that we breathe, the layer that protects us from solar radiation, the layer that creates our weather and our climate, looks remarkably thin. If you were to shrink the Earth to the size of a basketball, the atmosphere would be about the thickness of a coat of varnish painted on its surface, just a thin, delicate shell of air, held in place by gravity, separating us from the vacuum of space. This shell of air is what makes Earth comfortable and habitable. Without it, the surface would be cold and airless, like the moon. With too much of it, or the wrong kind, it would be hot and hostile, like Venus. We live within a very narrow range of conditions, sustained by a thin, fragile layer of air, quietly separating the living from the void. Fact 37. Slowly, gently, let us think about the International Space Station. The International Space Station orbits Earth at an altitude of about 400 kilometers, traveling at roughly 28,000 kilometers per hour. At that speed, it completes one full orbit of the Earth in about 90 minutes. The astronauts aboard the station see 16 sunrises and 16 sunsets every 24 hours. The station is about the size of a football field, including its large solar panel arrays, and it has been continuously inhabited since November 2000. Inside, the crew work on scientific experiments, maintain the station's systems, and occasionally, in their limited free time, look out the windows at the Earth below and the stars above. Several astronauts have described looking out at Earth from the station and feeling a profound sense of calm, a quiet recognition of how small and beautiful our world is, seen whole and entire from above. Fact 38. There is no need to rush. Let us rest with the idea of stellar distances. Within our galaxy, the nearest star to our Sun, Proxima Centauri, is about 4.2 light-years away. In terms of everyday distances, that is 40 trillion kilometers. If you were to travel there at the speed of a commercial aircraft, about 900 kilometers per hour, the journey would take about 5 million years. The next nearest star systems are also several light-years away. The stars we see in the night sky look close together, as if you could reach out and touch them from one to the other, but the spaces between them are almost incomprehensibly vast. Yet they are all part of the same galaxy, all bound together by gravity, all slowly orbiting the galactic center. Together, neighbors, in the most expansive sense of the word, quietly coexisting across distances that dwarf anything we encounter in our ordinary lives. Fact 39. Gently moving forward, let us think about tidal forces. The moon's gravity affects Earth in several gentle ways, and the most familiar is the tides. The moon's gravitational pull is slightly stronger on the side of Earth facing the moon, Then on the far side, this small difference in gravitational strength stretches the Earth slightly, not the solid rock, which is too rigid, but the oceans, the water on the side, facing the moon, bulges slightly outward, and so does the water on the opposite side, for more complex gravitational reasons. As Earth rotates, beneath these two bulges, most coastal places experience two high tides and two low tides every day. This has been happening for billions of years. The tides are a gentle conversation between the Earth and the moon, carried on in the language of gravity, quietly, continuously, night and day, whether anyone is watching or not. Fact 40. Now, as we continue, let us think about how the planets were formed. About 4.5 billion years ago, a cloud of gas and dust began to collapse under its own gravity, forming the young sun. At its center, the remaining material, a flat disk of gas and dust, began slowly circling the new sun. Within this disk, tiny particles of solid material began to stick together, forming small clumps, then larger ones, then objects the size of boulders, then mountains, then small planets, called planetesimals. These planetesimals collided and merged over millions of years, gradually accumulating mass, until the 8 planets we know today had formed. The whole process took tens of millions of years. Slow, gentle, patient. The solar system is not a creation that happened quickly. It assembled itself, piece by piece, over vast stretches of time, in a process that was quiet and methodical and utterly unhurried. Fact 41. Let us take a quiet moment to think about eclipses. A solar eclipse occurs when the moon passes directly between the Earth and the sun, briefly blocking the sun's light from reaching a narrow path across Earth's surface. What makes solar eclipses so remarkable and so improbable is that the moon and the sun appear almost exactly the same size. In our sky, the sun is about 400 times larger in diameter than the moon, but also about 400 times farther away, which means they appear almost identical in angular size. This alignment is a remarkable coincidence. No other planet in the solar system has a moon that so precisely matches the apparent size of its star. During a total solar eclipse, the moon covers the sun's bright face perfectly, revealing the sun's outer atmosphere, the corona, a soft, pale halo of light that is normally invisible, delicately glowing around the dark circle of the moon. Fact 42. Slowly, gently, let us think about meteor showers. Several times each year, Earth passes through a stream of debris left behind by a comet. When the tiny particles of dust and rock in that debris stream enter Earth's atmosphere, they burn up from friction, creating brief streaks of light across the sky. These are meteor showers, and they are among the most peaceful of all astronomical spectacles. You simply lie on your back on a warm night, look up at a dark sky, and wait. After a few minutes, a streak of light will appear, just a momentary flash, there, and gone, followed by another, and another. The Perseid meteor shower in August and the Geminid meteor shower in December are the most reliable and prolific of the annual showers. Each meteor is typically a piece of debris, no larger than a grain of sand, burning up completely, high in the atmosphere, silently, leaving nothing behind but a fading glow. Fact 43. There is no need to rush. Let us rest with the concept of gravity waves. In 2015, scientists detected something extraordinary. For the first time, gravitational waves. These are literally ripples in the fabric of space-time, created by massive, violent events, such as two black holes merging or two neutron stars colliding. Albert Einstein had predicted the existence of gravitational waves in his general theory of relativity in 1916, but they were considered so faint that many doubted they would ever be detected. When the LIGO detectors finally captured their signal, the ripple measured was a change in length of about 4 kilometers of detector by a distance smaller than 1,000th the diameter of a proton. Spacetime itself had been gently shimmering past us, rippled by events that happened over 1 billion light-years away. The universe was sending us tiny, quiet vibrations of its most powerful moments, and we had finally learned to listen. Fact 44. Gently moving forward, let us think about the North Star. The North Star, Polaris, appears to stand almost perfectly still in the night sky, while all other stars appear to circle slowly around it. This is because Polaris happens to be located very close to the North Celestial Pole, the point in the sky directly above Earth's North Pole. As Earth rotates, stars appear to circle around this point, but Polaris barely moves. For thousands of years, travelers and sailors used Polaris to find their direction. At night, it is not the brightest star in the sky, not even close, but its reliability and steadiness made it invaluable. Polaris will not always be the North Star. However, Earth wobbles very slowly on its axis, like a gyroscope, a motion called precession, and over a cycle of about 26,000 years, the North Celestial Pole traces a slow circle among the stars. Other stars take turns being the pole star, each one, in its time, quietly, steadily, holding the north. Fact 45. Now, as we continue, let us think about the seasons. Earth's axis is tilted at about 23.5 degrees relative to its orbit around the Sun. It is this tilt, not our distance from the Sun, which actually varies relatively little, that causes the seasons. When the northern hemisphere is tilted toward the Sun, it receives sunlight at a more direct angle, and for longer. Each day, summer, when it tilts away, the sunlight is spread more thinly across the surface, and days are shorter. Winter, the southern hemisphere, experiences the opposite pattern. The solstices, the longest and shortest days of the year, and the equinoxes, when day and night are of equal length, have been tracked by human cultures for thousands of years. They mark a rhythm older than civilization, a slow turning of the Earth in space that has been shaping life on this planet since before there were any creatures to feel the warmth of the longer days. Fact 46. Let us take a quiet moment to think about the heliosphere. The Sun does not simply emit light and heat, it also constantly releases a stream of charged particles called the solar wind. This stream of particles flows outward in all directions at hundreds of kilometers per second, filling the solar system with a gentle, invisible flow of energy. The region of space within which the Sun's solar wind exerts a dominant influence is called the heliosphere. It extends far beyond the orbit of Pluto to a boundary called the heliopause, where the solar wind finally gives way to the interstellar medium. The Voyager spacecraft crossed the heliopause and entered interstellar space, becoming the first human-made objects, to leave the sun's protective bubble. Within the heliosphere, we are somewhat shielded from certain forms of cosmic radiation by the sun's magnetic field and solar wind. We live, all of us, inside this great, invisible, constantly flowing bubble of solar energy. Fact 47. Slowly, gently, let us rest now with the idea of nebulae. The word nebula comes from the Latin for cloud or mist, and these vast clouds of gas and dust scattered throughout our galaxy are truly among the most beautiful things in the universe. Some nebulae glow with their own light, energized by the radiation of hot, young stars within or near them. Others are dark, absorbing and blocking the light of stars behind them, appearing as dark patches against brighter backgrounds. Still others reflect the light of nearby stars, glowing with a gentle blue sheen. The Crab Nebula is the expanding remnant of a supernova explosion that was observed by Chinese astronomers in the year 1054. It was so bright, it could be seen in the daytime for weeks. What they saw was a dying star throwing off its outer layers at thousands of kilometers per second. Nearly 1,000 years later, that expanding cloud of debris is still spreading outward, slowly, quietly, the ghost of a long-ago explosion. Fact 48. There is no need to rush. Let us think about the concept of a galaxy cluster. Galaxies are not scattered randomly. Through space, gravity draws them together into groups and clusters. Our own Milky Way belongs to a small group called the Local Group, which contains about 80 galaxies, including the Andromeda Galaxy and the Triangulum Galaxy. The Local Group is itself part of a larger structure called the Virgo Supercluster, which contains over 1,000 galaxies, and the Virgo Supercluster is part of an even larger structure called the Laniakea Supercluster, which contains about 100,000 galaxies and spans 500 million light-years. These vast structures, clusters of galaxies, are the largest structures in the observable universe, and yet they are themselves not randomly arranged. They form a cosmic web, a network of filaments and sheets of matter separated by vast, nearly empty voids. The universe has structure at every scale, all the way up. Fact 49. Gently moving forward, let us think about the life of our sun. Our sun is a yellow dwarf star, a fairly ordinary type of star, neither unusually hot nor unusually cool, neither unusually large nor unusually small. It formed about 4.5 billion years ago from a collapsing cloud of gas and dust. At its core, it fuses approximately 600 million tons of hydrogen into helium every single second, a process that releases an enormous amount of energy in the form of light and heat. This energy takes a surprisingly long time to escape from the sun's core. A photon of light generated at the sun's core may take anywhere from 10,000 to 170,000 years, bouncing around inside the dense solar interior before it finally reaches the surface and can escape into space. Once free, it travels the 150 million kilometers to Earth in about 8 minutes and 20 seconds, a very long wait for a very fast journey. Fact 50. Now, as we continue, let us think about auroras. When charged particles from the solar wind reach Earth, they are mostly deflected by our planet's magnetic field, but near the poles, where the magnetic field lines converge and point down toward the surface, Some of these particles are guided down into the upper atmosphere. There, they collide with molecules of oxygen and nitrogen, energizing those molecules and causing them to emit light, the shimmering, dancing curtains of light we call auroras in the northern hemisphere. They are called the aurora borealis, or northern lights, in the southern hemisphere, the aurora australis. The colors depend on which gas is being excited and at what altitude. Oxygen at high altitudes produces red. Oxygen at lower altitudes produces green. Nitrogen produces blue and purple. They move and ripple across the sky like slow, luminous curtains of color, visible on clear nights. Near the poles, utterly silent, utterly beautiful. Fact 51. Let us take a quiet moment to think about binary star systems. Many stars, perhaps more than half of all the stars in the Milky Way, are not alone. They exist in pairs, or small groups, orbiting each other in a slow, gravitational dance. These are called binary star systems. The two stars in a binary system can be very close together, orbiting each other in hours, or very widely separated, orbiting each other over thousands of years. Some binary stars are so close that they exchange material, gas flowing from one star to the other in a delicate stream. When enough material accumulates on one star, it can trigger a sudden burst of nuclear fusion, a nova, before settling down again. Others are more distant, simply slowly orbiting, each one a sun in its own right, casting the light of two suns on any planets that might exist. Between them, a world with two suns would have a very different sky, two gentle lights, two sets of shadows, two dawns. Fact 52. Slowly, gently, let us think about the cosmic web. On the very largest scales, the universe is not uniformly filled with matter. Galaxies and clusters of galaxies tend to form along vast filaments of dark matter, long, curving threads of invisible material, spanning hundreds of millions of light years, where several filaments intersect. Great clusters of galaxies accumulate between the filaments, lie immense, empty voids, hundreds of millions of light years across, nearly devoid of any matter at all. From a distance, far enough to see the whole structure. If such a perspective were possible, the universe would look something like a three-dimensional spider's web, or perhaps the internal structure of a sponge, or the complex network of neurons inside a brain. It is a pattern that emerges from simple gravitational physics, playing out over billions of years on a scale beyond imagination. The largest structure there is, and it is delicate and intricate and quietly beautiful. Fact 53. There is no need to rush. Let us rest with the history of stargazing. Human beings have been looking up at the stars for as long as there have been human beings. The oldest known astronomical artifact is the Nebra sky disk, found in Germany, which is about 3,600 years old, and depicts the Sun, Moon, and Pleiades star cluster. But humans almost certainly tracked the movements of the stars long before that. Ancient cave paintings may contain representations of star clusters tens of thousands of years old. The night sky was an important resource for early human cultures. A calendar, a navigation system, a source of stories and meaning. people named the star patterns, told stories about them, used them to track the seasons and guide their journeys. Looking up was not simply curiosity, it was practical, spiritual, fundamental. The stars have always been our companions in the dark. Fact 54. Gently moving forward, let us think about Galileo. In 1609, an Italian mathematician and astronomer named Galileo Galilei pointed a small, handmade telescope at the sky and changed our understanding of the cosmos forever. He saw craters and mountains on the moon, proving it was not a perfect, smooth sphere. He saw the phases of Venus, proving it orbited the sun. He saw for small moons orbiting Jupiter, proving that not everything orbited Earth. And he saw more stars than anyone had ever imagined. The Milky Way dissolving into countless individual points of light under the magnification of his glass. Each of these observations was a quiet revolution. The universe, Galileo revealed, was vaster, stranger, and more wonderful than anything previously imagined, and he saw it all through a tube with lenses no more powerful than a modern pair of binoculars in the quiet of a northern Italian night. Fact 55. Now, as we continue, let us think about the Pioneer plaques. In 1972 and 1973, NASA launched the Pioneer 10 and Pioneer 11 spacecraft, both of which were on trajectories that would eventually take them out of the solar system. Each spacecraft carried a small, gold-anodized aluminum plaque, designed by Carl Sagan and Frank Drake, and illustrated by Linda Salzman Sagan. The plaque depicts a man and a woman standing in front of the spacecraft, a diagram of our solar system, the position of our sun relative to 14 pulsars, and the structure of a hydrogen atom. It is a quiet message, a gentle introduction, saying, here is who we are, here is where we live, here is what we are made of. It is very unlikely that these small spacecraft will ever be found, but the people who designed the plaques understood that it was worth trying, that reaching out into the dark, even with little hope of reply, is simply the right thing to do. Fact 56. Let us take a quiet moment to think about the overview effect. Several astronauts, upon looking back at Earth from space, have described a powerful, lasting psychological shift, a feeling of deep calm, perspective, and connection. They see the Earth as a small, fragile, beautiful sphere, no borders, no divisions, just blue and white, and alive against the black void. This experience has been given a name, the overview effect. Astronauts describe returning from space with a changed sense of what matters, a deeper appreciation for the fragility of life, a persistent feeling of connection to all of humanity. From space, the categories and conflicts that seem so important from the ground dissolve. The whole thing, all of it, is just one small, warm, living world, alone, in a great silence. Some have said it is the closest thing to a spiritual experience they have ever had. Fact 57. Slowly, gently, let us think about Carl Sagan and the pale blue dot. In 1990, the Voyager 1 spacecraft was requested to turn its camera back toward the sun and photograph the planets of our solar system. One of those photographs showed Earth from a distance, of about 6 billion kilometers. As a tiny, barely visible point of light, less than a single pixel in size, caught in a beam of scattered sunlight, Carl Sagan, who had requested the photograph, wrote about it with extraordinary tenderness. He described our world as a mote of dust, suspended in a sunbeam. He noted that every human being who had ever lived, every king and farmer and philosopher, every act of kindness and cruelty and love had happened on that tiny point of pale blue light. It is one of the most quietly profound things anyone has ever said about our place in the cosmos, and the photograph itself remains one of the most quietly humbling images ever made. Fact 58. There is no need to rush. Let us rest with the Drake equation. In 1961, astronomer Frank Drake proposed a mathematical formula for estimating the number of intelligent civilizations in the Milky Way that might be capable of communicating with us. The Drake equation takes into account the rate of star formation, the fraction of stars with planets, the fraction of those planets that might support life, and several other factors. The equation doesn't give us a precise answer. We don't know the values of most of its variables well enough for that, but it gives us a framework for thinking about the question, depending on how optimistic or pessimistic you are about various factors. The estimated number of communicating civilizations in the galaxy can range from one, just us, to millions. The uncertainty is vast. The question is one of the deepest anyone has ever asked. And tonight, as you rest, the radio telescopes are quietly listening, scanning the sky, waiting. Fact 59. Gently moving forward, let us think about time dilation, one of the most beautiful and strange predictions of Albert Einstein's theory of relativity is that time does not pass at the same rate for everyone. Time runs slightly slower in a stronger gravitational field and slightly slower for objects moving at high speed. These effects are real and measurable, so real that the GPS satellites orbiting Earth have to account for them in their calculations, or they would quickly give inaccurate positions. For an astronaut moving at close to the speed of light, time would pass more slowly relative to someone left behind on Earth. If it were possible to travel at nearly the speed of light to a nearby star and back, only a few years might pass for the traveler, while decades passed. On Earth, time is not a fixed, universal clock. It is flexible and gentle, and it bends with gravity and speed in ways that are deeply, quietly surprising. Fact 60. Now, as we continue, let us think about the Chandrasekhar limit. In 1930, a young Indian astrophysicist named Subramanian Chandrasekhar was on a ship sailing from India to England, and he used the quiet hours of the voyage to calculate what happens to a dying star that collapses into a white dwarf. He found that there is a maximum mass that a white dwarf can have, about 1.4 times the mass of our sun, and that any white dwarf exceeding this mass cannot be supported against collapse by the quantum pressure of electrons. It was a profound theoretical insight, and it was not immediately accepted. The great astronomer, Arthur Eddington, publicly ridiculed the idea, But Chandrasekhar was right. The limit, he calculated, now bears his name, and understanding it was crucial to understanding supernovae, neutron stars, and black holes. He did this important work quietly, aboard a ship, watching the ocean, thinking carefully about the lives of stars. Fact 61. Let us take a quiet moment to think about absolute zero. Temperature is a measure of the kinetic energy of atoms and molecules. The faster they move, the hotter they are. As a substance is cooled, its particles slow down. At absolute zero, minus 273.15 degrees Celsius, or 0 Kelvin, particle motion reaches its minimum possible state. You cannot actually reach absolute zero. You can only approach it asymptotically, getting closer and closer, but never quite arriving. The coldest places in the known universe are not in the depths of space, but in physics laboratories on Earth, where scientists have cooled systems to within billionths of a degree of absolute zero. The coldest natural regions of space, the Boomerang Nebula, for example, sit at about 1 Kelvin. This is colder than the cosmic microwave background, making the Boomerang Nebula the coldest known, naturally occurring region in the universe. Cold and dark and far away and very, very still. Fact 62. Slowly, gently, let us think about the concept of entropy. The second law of thermodynamics tells us that systems tend to move toward greater disorder. That entropy, a measure of disorder, tends to increase over time. This is why ice melts in a warm room, why ice spreads when dropped in water, why systems left to themselves become more disordered over time. In the universe as a whole, entropy is slowly increasing. The organized structures around us, stars, planets, living things, exist because energy flows through them and maintains their organization. But eventually, the stars will burn out one by one. The last stars will fade. Black holes will slowly evaporate. Matter itself may eventually decay. The universe is thought to tend, in the very long run, toward a state called heat death, a state of maximum entropy, maximum disorder, complete uniformity, complete stillness. This is thought to be perhaps 10 to the power of 100 years away. For now, there is still plenty of time to simply rest. Fact 63. There is no need to rush. Let us rest with the idea of redshift and blueshift. When a light source moves away from an observer, the waves of light are stretched out, shifted toward the red end of the spectrum. When a light source moves toward an observer, the light waves are compressed, shifted toward the blue end. This is called the Doppler effect. For light, analogous to the way a passing ambulance's siren sounds higher in pitch as it approaches and lower as it recedes. By measuring the redshift or blueshift of light from distant stars and galaxies, astronomers can determine how fast they are moving relative to us and in which direction. Most distant galaxies show redshift. They are moving away from us as the universe expands, but the Andromeda Galaxy actually shows blueshift. It is moving toward us, drawn by gravity. In about 4.5 billion years, the Andromeda Galaxy and the Milky Way will gently, slowly collide. Fact 64. Gently moving forward. Let us think about space telescopes we have placed several remarkable telescopes. In space, above the distorting effects of Earth's atmosphere, the most recent and powerful is the James Webb Space Telescope. Launched in December 2021, Webb is positioned about 1.5 million kilometers from Earth at a stable gravitational point called L2. Its primary mirror is 6.5 meters across, made of 18 hexagonal, gold-coated beryllium segments, folded for launch, and then carefully unfolded and aligned in space over weeks of precise, patient work. Webb observes primarily in infrared light, allowing it to see through dust clouds that block visible light and to detect the ancient, redshifted light of some of the earliest galaxies in the universe. Its first images, shared in 2022, were among the most detailed and beautiful ever captured of the cosmos, each one a window into the deep past, open quietly among the stars. Fact 65. Now, as we continue, let us think about the layers of Earth's atmosphere. The atmosphere is not a simple, uniform layer of air. It is divided into several distinct regions, each with different properties. The troposphere, where our weather occurs, extends to about 12 kilometers above the surface. Above that, the stratosphere, which contains the ozone layer that absorbs harmful ultraviolet radiation from the sun, extends to about 50 kilometers. Then the mesosphere, where meteors burn up, reaches to about 85 kilometers. The thermosphere, where auroras occur, and the International Space Station orbits, extends to about 600 kilometers. And then, the exosphere, the outermost layer, gradually fades into the vacuum of space. These layers were not designed or planned. They emerged from the physics of gases, gravity, and the sun's radiation, arranging themselves into a gentle, layered structure that has been quietly maintaining the conditions for life on the surface below. Fact 66. Let us take a quiet moment to think about the zodiacal light. On very clear nights, far from city lights, you can sometimes see a faint, diffuse cone of light rising from the horizon where the sun has set, angled along the plane of the solar system. This is the zodiacal light, sunlight scattered by a disk of fine dust that fills the inner solar system. The dust mostly comes from comets and asteroid collisions, slowly ground down into particles smaller than the width of a hair. The zodiacal light is faint, much fainter than the Milky Way, and requires very dark skies to see, but it has been observed throughout human history, sometimes mistaken for the first light of dawn, sometimes called the false dawn. It is the quiet glow of billions of microscopic dust particles, each one briefly catching the sun's light and scattering it gently back toward our waiting eyes. Fact 67. Slowly, gently, let us think about the Milky Way as seen from Earth, from a dark location, far from city lights. The Milky Way is visible as a soft, pale band of light arching across the sky. From horizon to horizon, it is the combined light of hundreds of billions of stars in our galaxy, stars so distant and so numerous that they blur together into a gentle glow. Within this band, you can see dark regions, patches where dense clouds of dust block the light of the stars behind them. These are the same dark nebulae that will one day collapse to form new stars. The ancient Greeks called the Milky Way the Via Lactea, the Milky Road. Many cultures have their own name for it and their own story about what it represents. In New Zealand, the Maori call it Te Aikaroa, the long fish. All of these names are simply ways of reaching toward the same quiet wonder, the river of light above us, carrying the distant glow of 100 billion suns. Fact 68. There is no need to rush. Let us rest with the idea of dark skies. For most of human history, everyone who ever lived beneath an open sky could see the Milky Way clearly. It was simply part of the night. But in the past century, as electric lighting has spread across the world, most people in developed countries have lost access to a truly dark sky. Light pollution, the diffuse glow of cities and towns, seen from above, now affects a large fraction of the world's population. The stars are still there. Of course, the Milky Way still arches overhead, but the scattered light of our own civilization makes it invisible to most eyes. Most nights, organizations around the world work to preserve dark sky areas, places where the night sky can still be seen in its ancient, full glory. On the darkest nights, in the remotest places, the sky is so full of stars that the spaces between them seem dark by comparison to the brightness of the sky itself. Fact 69. Gently moving forward, let us think about the concept of exoplanets. For most of human history, we did not know whether any stars, other than our sun, had planets orbiting them. We suspected they might. It seemed reasonable, but we had no way to prove it. The first confirmed detection of exoplanets, planets orbiting other stars, came in the early 1990s. Since then, the flood of discoveries has been remarkable. As of 2024, more than 5,500 exoplanets have been confirmed, with thousands more candidates awaiting confirmation. They come in an extraordinary variety: gas giants, larger than Jupiter; small rocky worlds, like Earth; super-Earths, larger than our planet, but smaller than Neptune; and strange types, with no analog in our own solar system. Some orbit in the habitable zones of their stars, the range of distances where liquid water might exist on the surface. Some have two suns. The universe is full of worlds. We have barely begun to count them. Fact 70. Now, as we continue, let us think about the transit method for detecting exoplanets. The most successful method for finding exoplanets is the transit method. When a planet passes in front of its star, from our perspective, it blocks a tiny fraction of the star's light. By measuring that tiny dip in brightness, sometimes as small as 1/100th of a percent, astronomers can detect the passage of a planet. The Kepler Space Telescope, launched in 2009, monitored over 150,000 stars simultaneously. For these tiny dips, it found over 2,700 confirmed exoplanets before its mission ended in 2018. Each one represents a world, a place in space, orbiting a distant sun, detected not by seeing it directly, but by the quiet, patient measurement of a tiny, momentary dimming of starlight. Most of what we know about planets around other stars was learned by simply watching for faint shadows with great care and great patience over many years. Fact 71. Let us take a quiet moment to think about comets. Comets are ancient objects, some of the oldest, most pristine material in the solar system. They formed in the outer solar system, where it was cold enough for ices to condense, and most have been drifting, undisturbed, in the deep outer reaches of the solar system for billions of years. When something disturbs their orbit and they fall inward toward the sun's heat causes their ices to sublimate, turning directly from solid to gas, releasing dust and gas that form the comet's glowing coma and tail. A comet's tail always points away from the sun, no matter which direction the comet is traveling, because it is blown by the solar wind. The tail of a bright comet can be hundreds of millions of kilometers long, stretching across a significant fraction of the inner solar system, a delicate, glowing structure made of the most ancient ice, slowly melting in the sun's warmth. Fact 72. Slowly, gently, let us think about the asteroid belt. Between the orbits of Mars and Jupiter lies a region called the asteroid belt, home to millions of rocky and metallic objects, ranging in size from tiny pebbles to Ceres, the largest asteroid, about 945 kilometers in diameter, large enough to be classified as a dwarf planet, despite being called a belt and depicted in science fiction films as a treacherous obstacle course of densely packed rocks. The asteroid belt is actually mostly empty space. The total mass of all objects in the asteroid belt is less than 4%. The mass of our moon. If you were traveling through the belt in a spacecraft, you would be highly unlikely to encounter any large asteroid. They are spread across an enormous volume. The belt is a quiet, largely empty region. Its rocks slowly orbiting the sun in peaceful, unhurried paths. Fact 73. There is no need to rush. Let us rest with Halley's Comet. Among the most famous comets is Halley's Comet, which visits the inner solar system roughly every 75 to 76 years. It has been observed and recorded throughout human history, appearing in the Bayeux Tapestry, which depicts the Norman conquest of England in 1066, when the comet appeared in the sky above the armies. Ancient Chinese records mention it as far back as 240 BC. Every time it appears, a new generation of people see, for the only time in their lives, the same object that their grandparents and their grandparents' grandparents and generations, stretching back into prehistory, watched moving slowly through the same night sky. Halley's Comet last appeared in 1986 and is expected to return around 2061. When it does, the most elderly people who see it will be the same young children who see it, tonight's clear sky, with wondering eyes. Fact 74. Gently moving forward, let us think about the moons of Mars. Mars has two small moons, named Phobos and Deimos, named for the sons of Ares, the Greek god of war, the counterpart of the Roman Mars. Phobos and Deimos are tiny. Phobos is only about 27 kilometers across, and Deimos is even smaller, at about 15 kilometers. They are irregularly shaped and heavily cratered, and are thought to be captured asteroids, rather than moons, that formed alongside Mars. Phobos orbits Mars so closely and so quickly that it rises in the west and sets in the east, the opposite of how our moon moves across our sky, and Phobos is very slowly spiraling inward toward Mars, losing orbital energy to tidal forces, in about 30 to 50 million years, Phobos will likely break apart under the tidal forces of Mars, forming a thin ring of debris around the planet, two small, unassuming worlds, slowly drifting through their quiet orbits. Fact 75. Now, as we continue, let us think about the Kuiper Belt. Beyond the orbit of Neptune lies the Kuiper Belt, a broad ring of icy objects extending from about 30 to 50 astronomical units from the Sun. It is similar in concept to the asteroid belt, but much larger and populated with icier objects. Pluto is one of the largest and best known Kuiper Belt objects. The Kuiper Belt is thought to contain hundreds of thousands of objects larger than 100 kilometers and trillions of smaller ones, short-period comets, those that orbit the Sun in less than 200 years, are thought to originate in the Kuiper Belt, knocked out of their orbits by gravitational perturbations and sent falling inward toward the Sun. The Kuiper Belt is a cold, dark, distant place, far from the warmth of the Sun, dimly lit, slowly rotating. It is the quiet, outer suburb of our solar system, where ancient, icy remnants from the solar system's formation drift in their cold, patient orbits. Fact 76. Let us take a quiet moment to think about water in space. Water, the simple molecule of two hydrogen atoms and one oxygen atom, is one of the most abundant molecules in the universe. Ice has been found in the rings of Saturn, in comets, in asteroids, in the polar regions of Mercury, on the moons of Jupiter and Saturn, in distant nebulae, and in the cold, molecular clouds. Between the stars, liquid water exists beneath the icy surfaces of Europa, Enceladus, and possibly several other moons. In the outer solar system, water ice was even detected on the Moon, in permanently shadowed craters near the poles, where sunlight never reaches. The ubiquity of water in the universe is one of the reasons scientists are optimistic about the possibility of life elsewhere, not because life requires liquid water in exactly the same way Earth life does, but because water's chemistry is so versatile that it seems a natural medium for the complexity that life requires. Fact 77. Slowly, gently, let us think about the Enceladus geysers. Enceladus is a small, icy moon of Saturn, just about 500 kilometers across. It is one of the brightest objects in the solar system. Its surface is almost perfectly white, reflecting sunlight with great efficiency. In 2005, the Cassini spacecraft discovered something extraordinary: enormous geysers erupting from the south polar region of Enceladus, shooting plumes of water vapor and ice particles hundreds of kilometers into space. These geysers are fed by a liquid water ocean beneath the ice, kept liquid by tidal heating from Saturn's gravity. The plumes contain not only water, but also organic molecules, hydrogen gas, and silica particles, materials that suggest hydrothermal activity on the floor of Enceladus's ocean. This tiny, distant, ice-white moon has a warm, chemically active ocean churning quietly beneath its frozen surface. It is considered one of the most promising places in the solar system to search for life. Fact 78. There is no need to rush. Let us rest with amino acids. In meteorites, life on Earth is built from organic molecules particularly proteins, which are made of chains of amino acids. Scientists have discovered, to their wonder, that amino acids are not unique to Earth. They have been found in meteorites, ancient chunks of rock and metal from space that have fallen to Earth's surface. The Murchison meteorite, which fell in Australia in 1969, contains dozens of different amino acids, including several that are used in life on Earth, but also many that are not. This suggests that the basic chemical building blocks of life can form in space through non-biological chemical processes and can be widely distributed throughout the cosmos. On meteorites and comets, the raw materials of life may be common, scattered through the universe, like seeds, waiting for the right conditions, a warm planet, liquid water, time to grow into something remarkable. Fact 79. Gently moving forward, let us think about extremophiles. Here on Earth, life has found a way to exist in environments we would have thought impossible a few decades ago. Extremophiles are organisms that thrive in extreme conditions, in temperatures above 100 degrees Celsius, in hydrothermal vents, on the ocean floor, in highly acidic environments, in highly salty environments, in the extreme cold of Antarctic ice, in the complete darkness, deep underground, and even in the intense radiation environment inside nuclear reactors. Some bacteria have been found alive in rocks kilometers below the surface of Earth. Some microorganisms can survive the vacuum of space. Life on Earth is persistent and creative in a deeply impressive way. The discovery of extremophiles has profoundly changed our thinking about where life might exist elsewhere, perhaps in the cold, salty ocean of Europa, or in the clouds of Venus, or on the floor of Enceladus's ocean. Life, it seems, finds a way, quietly, patiently, finding a way. Fact 80. Now, as we continue, let us think about the Fermi paradox. Given the vast size and age of the universe and the apparent abundance of planets that might support life, one might expect that we would have encountered some evidence of intelligent life by now. Signals from other civilizations, artifacts, visitors, and yet we have found nothing. This contradiction between the expectation that intelligent life should be common and the complete absence of any evidence for it is called the Fermi paradox, named for physicist Enrico Fermi, who reportedly asked, simply, "Where is everybody?" Many explanations have been proposed. Perhaps intelligent life is genuinely rare. Perhaps civilizations tend to destroy themselves before they can communicate across the stars. Perhaps they exist, but are not trying to communicate. Or perhaps their signals have not yet reached us. Or perhaps, just perhaps, we are simply not yet listening in the right way. The universe is vast and quiet, and so far, silent, but we have not been listening for very long. Fact 81. Let us take a quiet moment to think about radio astronomy. Light, visible light, is just one small part of the electromagnetic spectrum. There is also radio, microwave, infrared, ultraviolet, X-ray, and gamma-ray radiation, and astronomers use instruments designed to detect all of these. Radio telescopes, the largest of which are vast metallic dishes, sometimes hundreds of meters across, detect radio waves from space radio waves pass through gas and dust that blocks visible light, allowing radio astronomers to see deep into regions hidden to optical telescopes. Some of the most important discoveries in astronomy have been made with radio telescopes, including the cosmic microwave background, pulsars, and the first direct image of a black hole's shadow, obtained in 2019 by the Event Horizon Telescope, a global network of radio dishes working together as a single, Earth-sized instrument. All of these discoveries, made in quiet by listening carefully to the universe's softest whispers. Fact 82. Slowly, gently, let us think about the scale of a galaxy to truly appreciate the scale of the Milky Way. Consider this. If you shrank the entire Milky Way to the size of North America, about 5,000 kilometers across our entire solar system, including all the planets, and the Oort cloud would be smaller than a single grain of sand. One tiny grain of sand, somewhere on that continent, is our entire home. Every planet, every moon, every object ever touched or launched by human hands on a grain of sand, and the Milky Way is itself just one of 2 trillion galaxies in the observable universe. Perspective like this can feel overwhelming, but it can also feel deeply calming, a reminder that the scale of the universe far exceeds our anxieties, our worries, our daily concerns. Whatever weighs on you tonight is very small next to the quiet immensity of all this. Fact 83. There is no need to rush. Let us rest with the idea of stellar parallax. How do astronomers measure the distances to nearby stars? One of the oldest methods is parallax, the same principle that allows our 2 eyes to perceive depth by observing a nearby star from 2 different points in Earth's orbit, 6 months apart. When Earth is on opposite sides of the Sun, astronomers can measure the tiny shift in the star's apparent position against the background of much more distant stars. From this shift, they can calculate the star's distance by simple trigonometry. The Hipparcos satellite, launched in 1989, measured the parallax of over 100,000 stars. Its successor, the Gaia spacecraft, launched in 2013, has measured the parallax of over 1 billion stars. The distances these measurements reveal are staggering. Even the nearest stars are trillions of kilometers away, but we know the distances now with precision because someone was careful enough to measure them. Fact 84. Gently moving forward, let us think about spectroscopy. One of the most powerful tools in astronomy is spectroscopy, the analysis of the spectrum of light from distant objects. When light from a star passes through a prism or diffraction grating, it spreads into a rainbow of colors. Within that rainbow, there are dark lines, specific wavelengths of light absorbed by the atoms and molecules in the star's atmosphere. Each element absorbs a unique pattern of wavelengths, a spectral fingerprint. By analyzing these absorption lines, astronomers can determine the chemical composition of a star from billions of light years away. Hydrogen, helium, carbon, oxygen, iron, all identifiable by their unique spectral signatures. Spectroscopy allows us to know what distant stars are made of, how fast they are moving, how hot they are, and much more, all from the quiet analysis of light that has traveled for millions of years to fall, finally, upon our instruments. Fact 85. Now, as we continue, let us think about the Voyager Golden Record. More deeply, the Golden Record was a remarkable act of optimism. Carl Sagan chaired the committee that decided what to include on it: a collection of sounds and images of Earth, greetings in 55 languages, music from many cultures, including a Bach prelude, a Pygmy girl's initiation song, and Beethoven's Fifth Symphony, sounds of rain and thunder, surf, birds, whales, and a human heartbeat. It included photographs of people, animals, architecture, and food. It was carefully designed as a communication to any intelligent beings who might one day find the spacecraft. The committee knew that the chances of anyone finding the Voyagers in interstellar space are extraordinarily small, and yet they made the record anyway, with great care, because it seemed right, because it was an act of reaching out in hope, quietly, into the vast and silent dark. That quiet reaching is perhaps one of the most human things we have ever done. Fact 86. Let us take a quiet moment to think about magnetars. Magnetars are a rare type of neutron star with an extraordinarily powerful magnetic field, the strongest known magnetic fields in the universe, roughly 1 trillion times stronger than Earth's magnetic field. A magnetar's magnetic field is so powerful that, if one were located halfway between Earth and the Moon, it would erase the magnetic stripe on every credit card on Earth. Magnetars occasionally experience starquakes, fractures in their crystalline surface, caused by the stress of their extreme magnetic fields, which release enormous bursts of energy. Despite their violent nature, magnetars are objects of a kind of strange, extreme beauty, compact, dense, spinning in the dark, radiating their incredible energy quietly into the surrounding space, sometimes flaring briefly, before returning to their slow, patient rotation. They are among the most extreme objects in the universe, and they are held together, quietly, by forces we can barely imagine. Fact 87. Slowly, gently, let us think about the Horsehead Nebula, about 1,500 light-years from Earth. In the constellation Orion, there is a dark nebula, shaped quite remarkably like the head and neck of a horse. The Horsehead Nebula is a dense cloud of gas and dust, appearing dark against the bright reddish glow of the ionized hydrogen cloud behind it. It is about 3.5 light-years tall. Astronomers have identified young stars forming inside the Horsehead Nebula, just beginning their long lives, still gathering material from the surrounding cloud. The shape of the Horsehead is maintained by radiation from nearby hot stars, which evaporate the outer edges of the nebula. Over time, the shape will change and eventually disappear as the nebula is slowly eroded away. For now, it drifts in space, its familiar silhouette unchanged from when our ancestors looked toward those stars, and the first photographs of it were taken in the late 1800s. Fact 88. There is no need to rush. Let us rest with the concept of light echoes. When a star suddenly brightens in an outburst or nova, the light spreads outward in all directions. When that light reaches nearby clouds of dust, it illuminates them, creating an expanding ring of light, called a light echo, because the light illuminating the dust cloud takes different amounts of time. Depending on the geometry of the path, the echo appears to expand and change in complex, beautiful ways over months and years. Light echoes allow astronomers to determine the three-dimensional structure of dust clouds around stars by essentially watching a sphere of light expand through the cloud, and noting which parts light up when. They're a quiet, beautiful side effect of a star's outburst, ghostly rings of light, spreading outward through dust clouds. In the dark, the gentle aftermath of a moment of brightness, slowly fading as the light travels on. Fact 89. Gently moving forward. Let us think about Titan. Titan is the largest moon of Saturn, and the only moon in the solar system known to have a dense atmosphere. Titan's atmosphere is actually thicker than Earth's, roughly 1.5 times the surface pressure. It is composed mostly of nitrogen, with a haze of organic molecules. That gives it an orange color. And it has weather. Titan has lakes, rivers, and seas, but not of water. On Titan's surface, where temperatures hover around minus 179 degrees Celsius, methane and ethane are liquid. Instead of gas, there are methane rain showers, methane rivers carving channels in the surface, and methane seas near the poles. Titan has a slow, complex weather system, driven by methane, rather than water. Cassini-Huygens showed us a world of pale orange skies, dark methane seas, and icy plains, alien, and quiet, and eerily Earth-like, in its own strange way. Fact 90. Now, as we continue, let us think about the Butterfly Nebula, about 3,800 light-years from Earth. In the constellation Scorpius, there is a dying star, surrounded by the most beautiful of planetary nebulae, the Butterfly Nebula, also called NGC 6302. Its wings of gas span about 3 light-years, from tip to tip, glowing in magnificent blues, and oranges, and reds, as ultraviolet radiation from the dying star at the center energizes the expelled gas. The central star is one of the hottest stars known, with a surface temperature around 250,000 degrees Celsius. It is hidden within a dense disk of dust that forms the narrow waist. Between the two wings, the wings of glowing gas are moving outward at about 600 kilometers per second. And yet, in photographs, they appear utterly still, frozen in their beauty. It is one of the most beautiful things in the known universe, existing quietly among the stars, seen only by light. Fact 91. Let us take a quiet moment to think about stellar nurseries in other galaxies. The process of star formation happens not only in our own Milky Way, but throughout the universe. In the Tarantula Nebula, a vast star-forming region, in the Large Magellanic Cloud, a satellite galaxy of the Milky Way, stars are forming at a prodigious rate, driven by enormous amounts of gas and the radiation of many hot, young stars. The Tarantula Nebula is so bright that if it were as close to Earth as the Orion Nebula, it would cast shadows. At night, some of the most massive stars ever observed reside within it, stars perhaps 200 times the mass of our Sun, burning with extraordinary intensity. These massive stars will live fast and die young, in terms of cosmic timescales, ending their brief, brilliant lives in spectacular supernovae that will scatter their material back into the nebula, seeding the next generation of star formation, a gentle cycle playing out across billions of years. Fact 92. Slowly, gently, let us think about the Sun's activity cycle. The Sun is not perfectly constant. It goes through an approximately 11-year cycle of activity, driven by the behavior of its magnetic field. During solar maximum, the Sun's surface is marked by many sunspots, darker, cooler regions, where magnetic field lines emerge from the surface, and is more prone to solar flares and coronal mass ejections. During solar minimum, sunspot activity decreases, and the Sun is more quiet. These cycles have been recorded for hundreds of years. The Sun is currently in solar cycle 25, which began in December 2019. Solar activity affects Earth in subtle ways. Auroras are more frequent during solar maximum, and there are small effects on satellite communications and power grids during large solar events. But mostly, the Sun's 11-year cycle is simply a quiet rhythm, a long, slow breath of a star cycling between slightly more and slightly less active states, year after year. Fact 93. There is no need to rush. Let us rest with the idea of stellar populations. Astronomers classify stars into different populations based on their age and composition. The oldest stars, called population 2 stars, formed early in the universe's history when the only available elements were hydrogen and helium, the products of the Big Bang. These ancient stars are metal poor, and most of them orbit in the outer halo of the Milky Way or in old globular clusters. Younger stars, like our Sun, are called population 1 stars. They formed from gas, already enriched by previous generations of stellar nuclear fusion and supernova explosions, and contain much higher proportions of heavier elements. Our Sun's relative richness in carbon, oxygen, and iron is a product of the entire previous history of the galaxy, generations of stars that lived and died before our solar system formed, building up the chemical complexity that makes planets like Earth possible. We are, quite literally, the children of ancient stars. Fact 94. Gently moving forward, let us think about the edge of the solar wind when the Voyager spacecraft crossed the heliopause and entered interstellar space. The instruments detected something interesting. The magnetic field outside the heliopause was oriented differently from the field inside, and the density of charged particles changed. The boundary between the solar wind and the interstellar medium is not a sharp line. It is a zone of transition, a place where the pressure of the outward-flowing solar wind balances the pressure of the inward-pushing interstellar medium. The shape of the heliosphere, our Sun's protective bubble, is thought to be elongated, like a comet or a teardrop, with a blunt nose pointing in the direction of the Sun's motion through the galaxy, and a long tail extending behind. The Sun is always moving, always carrying its little bubble of influence through the galaxy, a tiny island of solar wind in the vast ocean of interstellar space. Fact 95. Now, as we continue, let us think about globular clusters scattered around the outer regions of the Milky Way, orbiting the galactic center in wide, sweeping paths, are about 150 densely packed spherical collections of stars called globular clusters. Each globular cluster contains anywhere from tens of thousands to several million stars, all very old, all gravitationally bound together in a tight, brilliant sphere. From a planet inside a globular cluster, the night sky would be extraordinarily different from ours. Instead of a few thousand stars visible to the naked eye, there might be tens of thousands of stars so bright that the night would never be truly dark. The stars would be close enough together that some would appear clearly as disks rather than points. Globular clusters are among the oldest structures in the galaxy. Most formed over 10 billion years ago, shortly after the Milky Way itself formed. They are ancient, dense, glittering, quietly orbiting. Fact 96. Let us take a quiet moment to think about the concept of a habitable zone. Around each star, there is a range of distances called the habitable zone, sometimes called the Goldilocks zone, where the temperature is right for liquid water to exist on the surface of a rocky planet. Not too hot, not too cold. In our solar system, Earth sits comfortably within this zone. Mars is at the outer edge. It is too cold now, though it may have been habitable in the past. Venus is inside the inner edge. Too hot. In recent years, astronomers have found several exoplanets in the habitable zones of their stars, including some rocky worlds of roughly Earth size. These planets are considered promising candidates for further study. None of them are within the reach of any spacecraft we could send in our lifetimes, but knowing they are there, rocky worlds orbiting other suns in the right temperature zone is quietly wonderful in a way that is hard to fully describe. Fact 97. Slowly, gently, let us think about stellar evolution diagrams. In the early 20th century, astronomers Ejner Hertzsprung and Henry Norris Russell independently discovered that if you plot the luminosity of stars against their surface temperature, most stars fall along a curving diagonal band called the main sequence. Stars on the main sequence are in the stable phase of their lives, fusing hydrogen into helium. The position of a star on the main sequence depends on its mass. More massive stars are hotter and more luminous. This simple diagram, the Hertzsprung-Russell diagram, revealed the life stories of stars to astronomers, showing how stars move through different stages of their lives. A star begins its life on the main sequence, then gradually moves off it as it ages. The diagram is not just a graph, it is a map of stellar lives, a quiet portrait of billions of years of stellar history, readable in a single page. Fact 98. There is no need to rush. Let us rest with the idea of the cosmic distance ladder. Astronomers have developed a series of methods for measuring cosmic distances, each one extending the reach of the previous method, building up, like rungs of a ladder, into the universe. The first rung is parallax, good for nearby stars. From there, astronomers use the known properties of certain types of stars, like Cepheid variable stars, which pulsate with a brightness that is directly related to their luminosity, to measure distances to nearby galaxies. Farther out, they use type Ia supernovae, which all explode with nearly the same intrinsic brightness. Each method overlaps with and validates the others, building a consistent picture of distances out to billions of light years. This patient, careful, multi-step process of measuring the universe is one of the great achievements of observational astronomy, a ladder built, rung by rung, over more than a century, reaching quietly toward the horizon of the observable universe. Fact 99. Gently moving forward, let us think about the Cassini mission to Saturn. The Cassini spacecraft arrived at Saturn in 2004 and spent 13 years orbiting the ringed planet, studying it in extraordinary detail. It flew through the plumes of Enceladus. It dropped the Huygens probe into the atmosphere of Titan, which parachuted down and became the first human-made lander on a world in the outer solar system. Cassini photographed Saturn's rings in breathtaking detail, discovered new moons, and observed the great storm that circles Saturn's north pole, a permanent hexagonal jet stream, each side longer than the diameter of Earth. In 2017, with its fuel running low, Cassini was deliberately directed into Saturn's atmosphere, where it burned up, chosen as the gentlest end to prevent any contamination of the moons that might harbor life. It sent data right up until the atmosphere was too thick for its signal to escape. A quiet, dignified end to a remarkable journey. Fact 100. Now, as we continue, let us pause on this, our 100th gentle fact, and take a slow, quiet breath. 100 quiet truths about the universe, laid out one by one, like stars. On a clear night, the universe is enormous and ancient and mostly silent. Stars are born and die in the slow cycles of cosmic time. Planets drift in their orbits, steady and patient. Light travels across the void, carrying ancient images of distant fires. And here we are, small and warm and alive, on a blue world, in the suburbs of an ordinary galaxy, one of perhaps trillions of worlds, scattered through the vast, quiet dark. There is no need to grasp all of this at once. It is enough simply to rest within it, to let the scale of things wash over you gently, like a tide coming in softly. On a calm night, 20 more quiet facts remain. Let them carry you further and further into rest. Fact 101. Let us take a quiet moment to think about the future of the sun. In about 5 billion years, when our sun exhausts its hydrogen fuel, it will swell into a red giant, expanding to perhaps 100 times its current size. Mercury and Venus will likely be swallowed. Earth's fate is less certain. It may be engulfed, or it may drift outward as the sun loses mass. But long before any of this, in about 1 billion years, the sun will be about 10% brighter than today, which may be enough to disrupt Earth's water cycle. In the very longest view, the sun is not a permanent fixture. It is a temporary arrangement, a fire that has been burning for 4.5 billion years, and will burn for about that long again. After that, it will leave behind a planetary nebula and a quiet, cooling white dwarf, slowly, gently, fading to darkness over trillions of years. Fact 102. Slowly, gently, let us think about the Andromeda collision. The Andromeda galaxy is approaching the Milky Way, drawn by gravity, at about 110 kilometers per second. In about 4.5 billion years, the two galaxies will begin to merge in a slow, enormous collision that will last several billion years. The night sky during the merger will be spectacular beyond imagination, full of new star clusters, glowing nebulae, and a dramatically altered arrangement of stars. But the collision itself will not destroy stars. The galaxies are too sparse for stellar collisions to be common. Individual stars will drift past each other. In the vast spaces between them, the two galaxies will gradually blend into one large elliptical galaxy, a process that takes billions of years. Gently and slowly, like two fog banks merging on a still morning, spectacular in their scope, gentle in their details. Fact 103. There is no need to rush. Let us rest with the concept of cosmic inflation. Current cosmological theory suggests that very shortly after the Big Bang, within the first tiny fraction of a second, the universe underwent a period of extraordinarily rapid expansion, called inflation, during which it grew from something unimaginably small to roughly the size of a grapefruit, in an instant of time far shorter than we can meaningfully comprehend. After inflation ended, the universe continued to expand, but much more slowly. Inflation explains several features of the universe that are otherwise difficult to account for, including why the cosmic microwave background is so remarkably uniform in temperature across the entire sky, and why space appears to be geometrically flat. On the largest scales, inflation is still a theory, still being refined and tested, but it represents a remarkable attempt to understand the first moments of everything, the very first breath of the universe, taken long before time had settled into the steady rhythm we know. Fact 104. Gently moving forward, let us think about the fate of black holes. Black holes are not permanent. In 1974, Stephen Hawking proposed that black holes slowly lose mass through a quantum process, now called Hawking radiation. The effect is caused by quantum fluctuations at the event horizon, which allow a tiny amount of energy to escape as radiation for a stellar mass black hole. Hawking radiation is extraordinarily faint, so faint it is completely undetectable with current technology, and the timescale for a black hole to evaporate completely through Hawking radiation is almost incomprehensible. For a black hole the mass of the Sun, it would take approximately 10 to the power of 67 years. But eventually, over vast cosmic ages, even black holes must fade. The last things in the universe will be the supermassive black holes at the centers of galaxies, growing colder and colder, dimmer and dimmer, until they too, slowly, gently, dissolve into the quiet. Fact 105. Now, as we continue, let us think about rogue planets. Not all planets orbit a star. It is estimated that there may be more free-floating rogue planets, planets not gravitationally bound to any star, than there are stars in the galaxy. These worlds were ejected from their solar systems during formation, sent tumbling into the interstellar dark by gravitational interactions with other planets. They drift alone in the cold between the stars, with no sun to warm them, no starlight to illuminate them. They are invisible to ordinary telescopes, not reflecting enough light to be seen across interstellar distances. Some rogue planets may be large enough and retain enough internal heat to maintain subsurface liquid water. Even without a star, there is a quiet loneliness to the image of a rogue planet, a world drifting through the dark, alone, unlit, unknown, but also something peaceful about it, drifting quietly in the dark, undisturbed, through the long ages of the universe. Fact 106. Let us take a quiet moment to think about the concept of a multiverse. Some interpretations of modern physics suggest that our universe, the one we inhabit and observe, may not be the only one. Different theoretical frameworks propose different kinds of multiverses. In some interpretations of quantum mechanics, every time a quantum event occurs with multiple possible outcomes, all outcomes happen, but in separate, branching universes. In the many worlds interpretation, the universe is constantly branching into a vast tree of parallel realities. In inflation theory, different regions of space may have undergone separate inflations, creating bubble universes with potentially different physical constants. These ideas are, for now, more in the realm of theoretical physics than observational science. We have no evidence for or against a multiverse, but the possibility, the quiet, enormous possibility, that our universe is just one of countless others, each one a complete cosmos, is one of the deepest thoughts the human mind has yet managed to think. Fact 107. Slowly, gently, let us think about the oldest stars. Among the stars in our galaxy, some are extraordinarily ancient, nearly as old as the universe itself. Stars like HD 140283, sometimes called the Methuselah star, have been measured to be about 14 billion years old, give or take a margin of error that puts them within the age of the universe. These old stars formed from the earliest material in the galaxy, mostly hydrogen and helium, with very little of the heavier elements that later stellar generations would create. They have been burning quietly in the outer halo of the Milky Way since near the very beginning, through the formation of our solar system, through the entire history of life on Earth, through the entirety of human history and prehistory. They were there before our sun existed. They are there now, burning quietly in the dark, the oldest living lights in the sky. Fact 108. There is no need to rush. Let us rest with the quiet beauty of double stars as seen from Earth. Many of what appear to be single stars in the night sky are, to a small telescope, revealed as two stars very close together. Binary systems that can be resolved by magnification into their individual components. In some cases, these are genuine binaries, orbiting each other. In other cases, called optical doubles, two stars that appear close together are actually at very different distances from Earth, and just happen to lie in nearly the same line of sight. Some of the most beautiful objects in the sky are colorful double stars, where one star is orange or red, and the other is blue or green, creating a tiny jewel-like pair. In the eyepiece of a telescope, Albireo, in the constellation Cygnus, is one of the most beloved of these, a golden star paired with a sapphire blue companion, a small, quiet, beautiful thing, waiting patiently in the sky for anyone who looks. Fact 109. Gently moving forward. Let us think about the concept of stellar remnants. After stars die, they leave behind remnants. White dwarfs, neutron stars, or black holes. Depending on their initial mass, these remnants endure long after the star itself has gone dark. A white dwarf takes trillions of years to cool completely into a black dwarf, a cold, dark, inert ball of carbon and oxygen, and the universe is not yet old enough for any white dwarf to have done so. No black dwarfs yet exist anywhere in the universe. They are a future thing, a future stage of stellar death that has not yet occurred even once. Every star that will ever be a black dwarf is still either alive or is a glowing white dwarf. In the process of cooling, we live in a universe young enough that its first generation of stellar remnants is still faintly glowing. In the incomprehensible depths of future cosmic time, the universe will grow darker, but that darkness is very, very far away. Fact 110. Now, as we continue, let us think about what space smells like. Several astronauts and mission specialists working on the International Space Station have described what space smells like when equipment returns from spacewalks. A faint, distinctive odor, clinging to spacesuits and tools. Descriptions vary. Some say it smells like metal or welding fumes. Some say it has a faint burnt or smoky quality. Some describe a sweet, seared smell. The odor is thought to come from the interaction of high-energy particles, protons and electrons from the solar wind, and cosmic rays with the materials of the spacesuit during the spacewalk, producing reactive compounds that are detected when the equipment is brought back inside. No one has smelled open space directly, of course, but the suggestion that space has even a faint, indirect scent, something metallic and burnt and ancient, is oddly comforting. Even the void between the stars has something to offer the senses, quietly, at the very edges of perception. Fact 111. Let us take a quiet moment to think about the silence of the night sky question. There is a deceptively simple puzzle, known as Olber's paradox. If the universe is infinite, eternal, and filled with stars in all directions, then every line of sight from Earth should eventually reach the surface of a star. The night sky should be blazing with light in every direction, as bright as the surface of the sun. And yet, the night sky is dark. Why? The answer has to do with the finite age of the universe and its expansion. The universe is not infinitely old. Light from the most distant stars has not yet had time to reach us, and the expansion of the universe shifts the light of distant objects into longer wavelengths, out of the visible range. The darkness of the night sky is not simply the absence of light. It is a consequence of the age and structure of the universe itself. The quiet darkness above you tonight is a clue to the history of everything. Fact 112. Slowly, gently, let us think about the concept of cosmic background neutrinos. the cosmic microwave background, is the most well-known relic from the early universe. But there's also a cosmic neutrino background, a sea of ancient neutrinos, left over from the first second after the Big Bang. These neutrinos are everywhere, passing through the Earth, through your body, through everything around you, right now, at nearly the speed of light, in numbers of about 336 per cubic centimeter, everywhere in space. They interact so weakly with matter that virtually all of them pass through the entire Earth without being deflected or absorbed. They have been traveling since 1 second after the Big Bang. They are, in a sense, the oldest particles in the universe, even older than the photons of the cosmic microwave background, passing through you, through the walls, through the planet below you, through the long cold dark of space, without stopping, quietly, always. Fact 113. There is no need to rush. Let us rest with the idea of the scale of the universe. If you were able to travel in a straight line at the speed of light, the fastest speed anything in the universe can travel, it would take you about 1.25 seconds to reach the moon, about 8 minutes and 20 seconds to reach the sun, about 4 years to reach the nearest star, about 100,000 years to cross our galaxy, about 2.5 million years to reach the Andromeda Galaxy, about 13.8 billion years to approach the edge of the observable universe, where the oldest light is only now arriving. These are not metaphors. These are actual distances. And beyond the edge of the observable universe, space continues, perhaps infinitely, in all directions, dark and vast and quiet, filled with whatever is out there that we cannot yet see, quietly present, quietly waiting, quietly beyond all reach. Fact 114. Gently moving forward, let us think about the concept of cosmic perspective. Looking at the night sky, really looking, has a way of gently dissolving certain concerns. The things that feel heavy and close in the daytime somehow seem lighter and more distant under a dark, starlit sky. This is not because they are unimportant. It is because the sky reminds us, gently, that we exist within a context so vast that almost nothing within it is truly beyond remedy. We are small, yes, but we are here. We are alive and conscious and capable of wonder. We have looked up at those same stars that every human who has ever lived has looked up at. We have thought the same thoughts of vastness and mystery that thoughtful people have always thought. On clear, still nights, there is a continuity in that, a quiet sense of belonging to something very large and very old and very beautiful. Fact 115. Now, as we continue, let us think about the gravitational lensing of light. When light from a distant object, a galaxy or quasar, passes near a massive object on its way to Earth, the gravity of that massive object bends the path of the light, acting like a lens. This gravitational lensing can distort, magnify, and even create multiple images of the distant object, arranged in arcs or rings around the lensing object. The most perfect gravitational lenses create complete, brilliant rings of light, called Einstein rings, named for Albert Einstein, who first predicted the effect. Gravitational lensing is not just a visual curiosity. It is one of the most powerful tools astronomers have for studying the distribution of dark matter, for detecting exoplanets, and for observing extremely distant galaxies that would otherwise be too faint to see. Gravity, quiet and invisible, bending the paths of ancient light across the universe. Even light does not travel in perfectly straight lines in a universe full of mass. Fact 116. Let us take a quiet moment to think about the longevity of white dwarfs. White dwarfs are the most common final stage of stellar evolution. The fate of most stars in the universe, including our own sun. A white dwarf has no ongoing nuclear fusion. It is simply the hot, dense core of a former star, slowly cooling over time. White dwarfs cool very slowly. The most massive and brightest white dwarfs take hundreds of billions of years to cool to the point where they would be considered black dwarfs. For the most part, even the first white dwarfs that ever formed, at least 10 billion years ago, are still glowing, still warm, still releasing the last of their stored heat into the quiet dark. They are patient objects, unhurried. They do not burst, or flare, or explode. They simply cool, slowly, over incomprehensible spans of time, like the last warmth fading from a stone that spent a long day in the sun. Fact 117. Slowly, gently, let us think about the resonance of planetary orbits. Some planets in the solar system maintain orbits that are in gravitational resonance with each other. Their orbital periods form simple ratios. For example, for every 2 orbits Neptune makes around the Sun, Pluto makes exactly 3. This 3:2 resonance protects Pluto from ever approaching Neptune closely, despite crossing Neptune's orbital path. The moons Io, Europa, and Ganymede, around Jupiter, are in a 4:2:1 resonance. For every 4 orbits of Io, Europa completes 2, and Ganymede completes 1. These resonances are not coincidences. They are gravitational harmonics, stable configurations that form naturally over time. As orbiting bodies exchange tiny amounts of energy, the solar system sings, in a sense, a very slow gravitational music, playing out over millions of years, keeping the planets and moons in their ordered, harmonious arrangements, a quiet song of gravity, holding everything gently in its place. Fact 118. There is no need to rush. Let us rest now with the idea of the night side of Earth. From space, Earth at night is a beautiful object, the sunlit side brilliant blue and white, and the night side dark, but dotted with the warm orange and yellow lights of human civilization. The cities appear as glowing clusters and threads, following the lines of coasts and rivers. Wildfires glow orange in remote regions. Auroras shimmer near the poles. Lightning flashes briefly in the clouds. The International Space Station passes over the night side of Earth. Every orbit, and the astronauts aboard describe the experience as deeply peaceful. The vast, quiet dark of Earth's shadow, with the lights of billions of lives, glowing softly below. Each little light is a home, a family, a warm room somewhere, on the surface of this blue world. All of it is visible at once, from above, in the dark, small, and warm, and alive. Fact 119. Gently moving forward. For the next to last time tonight, let us think about the concept of deep time. The universe is 13.8 billion years old. The Earth is 4.5 billion years old. The oldest rocks on Earth are about 4 billion years old. The oldest fossils are about 3.5 billion years old. The dinosaurs went extinct 66 million years ago. Modern humans appeared about 300,000 years ago. The oldest known writing is about 5,000 years old. Your own life, however long it has been, is an extraordinarily brief flicker in the context of these timescales. But this is not a cause for sadness. It is a cause for a particular kind of peace. In the scale of deep time, all the moments of your life are close together, all of them nearby, all the people you have loved, all the places you have been. They are all recent, all here, all part of the same brief, warm moment. In the scale of the universe, the entire human story is just a soft, quiet, recent thing. Fact 120. And now gently, we arrive at our 120th quiet fact of the evening. Let us think one last time about the night sky above you. Right now, at this very moment, the stars are there. You may not be able to see them. Perhaps there are clouds, or city lights, or simply a ceiling and walls between you and the sky. But they are there. They have always been there. Every star you have ever seen, every constellation you have ever recognized, every faint smear of the Milky Way you have ever glimpsed on a clear, dark night, all of it is there right now, quietly glowing. The light from those stars has been traveling toward this moment for years, for centuries, for millennia. It left those distant fires long before tonight, long before this week, or this month, or this year. It has been quietly journeying through the dark in a perfectly straight line at the speed of light for the entire time it has taken to reach your eyes. And tonight, at the end of a quiet journey across the void, it arrived, and so did you. And for a little while, the universe and you were quietly here, together, in the dark. And so, we come to the end of our quiet journey through the stars and the planets, through light and time and silence, through all the soft and patient wonders of the universe. We have traveled in our minds to the nearest stars and the farthest reaches of the observable cosmos. We have rested with dying stars and newborn nebulae, with ancient ice drifting in the outer dark, with the faint, eternal glow of the oldest light in the universe. And all along the way, the universe has asked nothing of us, only to be here, only to notice, only to be still. There is something very calming in the scale of it all, something that gently reminds us that the universe is patient, that it has been going about its quiet business for nearly 14 billion years, and that it will continue long after any particular worry or concern has dissolved, just as a star's light continues, long after the star itself has changed, just as the echo of the Big Bang still drifts through every corner of space, just as the tides move in and out along the shores of the earth, pulled by the moon's quiet gravity. On and on, the universe does not hurry. It does not worry. It simply continues, and you are part of it. You are made of its oldest material. The atoms in your body were forged in stars. The water in your cells has been cycling through the earth for billions of years. You are not separate from the universe. You are a brief, warm, conscious expression of it. And tonight, as you drift towards sleep, you can simply let the universe hold you. Let the quiet darkness of space extend outward in every direction, above and below, and to all sides, vast and still and safe. Let the stars do their slow, patient burning. Let the planets drift in their gentle orbits. Let the light keep traveling, as it has always traveled, in quiet straight lines, across the dark, and let yourself rest. There is nothing you need to do right now. There is nowhere you need to go. There is no problem that requires your attention tonight. Just rest. The universe is large enough to hold everything, all of it, every difficulty, and every joy, every question, and every answer not yet found, every distant star, and every sleeping heart. It holds all of it quietly, without effort, without end. You are resting now. The stars are there, even if you cannot see them. The galaxy turns, very slowly, in the dark. Somewhere, a new star is beginning to form. In the quiet depths of a nebula, somewhere, light that left a distant sun 1,000 years ago is still traveling, still on its way. The universe is patient, and so are you. Sleep well. Good night. If you enjoyed this quiet journey through space, and if you find yourself returning to these long, soft nights of wandering among the stars. A gentle like, or a quiet subscription, would mean more than you know. It helps more people find their way to nights like this one. But most of all, simply rest. The stars are watching over you. Good night.